Hello, welcome to today's class. I'm so glad you are here. In today's video, we shall be looking at use of Cramer's rule to solve equations. We can use Cramer's rule to solve simultaneous equations and equations that has more than two variables. Now, what is Cramer's rule? Cramer's rule uses determinants to solve systems of equations that have the same number of equations as variables. So we shall be looking at the methods or the how we can use Cramer's rule to solve equations. For example, we are given an equation in this form: ax plus by equal to c1 and dx plus ey equal to c2. Know that the x and y are the variables and the c1 and c2 are the constants. Now we can use Cramer's rule to solve this system of equation. How do we do that? The first thing is that we represent this equation in a matrix form. So I draw my square bracket, or I draw my determinants. So here, use a different marker. This is the top is the x column, is the y column, then equal to, this is my constant column. Okay, so now we put in the values or the numbers into this matrix. So here is my A, and I have what? D under the x variable. Then for the y, I have B and E. Then for the constants, we have C1 and C2. So this is the first step we do. We transform the equation into a matrix, in this case, a determinant matrix. From here, we can solve the matrix. Now, to find x, the formula we use is x is equal to determinant of d subscript x over determinant of d. To find our y, the formula we use is determinant of d subscript y over determinant of d. So what I'll be showing us now is how to get your d and your d subscript x and your d subscript y. Now let's start with our d. To get our determinant of d, what we do is that step one, we draw our determinant symbol. Now the element that goes into this determinant of d must be x and y. So to get the elements, or to get the columns in d, we ignore the constants. So what should be here should be what? The x column and the y column. So I have A, D, and B, and E. So this gives me the determinant of d. And please note that determinant of d must not be 0. It must not be 0. It must not be equal to 0. If the d determinant is 0, then we cannot use Cramer's rule to solve that equation. So note that the d determinant must not be 0. Okay, so to get my determinant of d subscript x, in this case, what I do is this. Step one again, I open my determinant bracket. Now, the columns that will go into this is y and the constant. To get the element or the number of columns that goes into the dx, I have to replace the x with the constant. So I replace AD with C1, C2, becomes C1, C2, then the y is there, b and e. So as you can see, to get my d determinant, I use x and y. We ignore the constant column. To get my dx, I ignore the x column and replace the x with the constants, and the y remains. That's it. Now, the same procedure goes for dy. To get my determinant of dy, I hope you can guess that now. So I open my matrix. What goes in here is the column in x and the constant column. So to get the columns in y, I have to replace the y with the constant. So what I have here is the x column and the constants column. So the x is AD, and for the constant, we have C1 and C2. So from here, we can find the determinant of x or of the x and for the y, and we can put them into this equation and we get our answers. All right, so this is how we use Cramer's rule to solve equations. And please remember that determinant of d must not be equal to 0. If it is equal to 0, then we cannot use Cramer's rule. Now, here is a question. We're asked to solve for x and y using Cramer's rule. Step 1, we transform this equation into a matrix. So I draw my symbols equal to. Remember that here is your x, here is the y column, and here is the constants. Okay. So what next? I put in the values. So for x, we have 3 and 5. So 3 and 5. For y, we have -4 and +1. -4 and 1. For the constants, we have 1 and 17. 1 and 17. So from this, we can solve for our d, dx, and dy. So let's start with our determinant of d. Determinant of d, that gives us, I open my matrix. For d, remember for d, we have what? Just x and y. For d, we ignore the column for the constant. So we have just 3 minus 4, 5, and 1. So therefore, d determinant is equal to, remember, to find the determinant of a 2 by 2 matrix, we multiply the leading diagonal and we subtract it from the non-leading diagonal. So it's 3 times 1, which is 3, minus, open brackets, 5 times -4 is -20. So therefore, we have 3 minus is a plus 20. So therefore, the determinant of d is equal to 23. So as you can see, my d determinant is not equal to 0. So I can use Cramer's rule. So I can continue. This is 3. All right, good. What next? Let's find dx. Again, I open my matrix. For x, we have to replace the x with the constant. So we have c y. So to get my dx, I use the constant and the y column. So I replace the x with the constant, so it becomes 117, and the y is -4 and 1. So I cannot find the determinant of this matrix. As you can see, it's a 2 by 2 matrix. Again, we multiply the leading diagonal minus the non-leading diagonal. So 1 times 1 is 1 minus 17 times 4 is 68. So that's negative 68. All right. So therefore, we have 1 minus gives us a plus 68. So therefore, my dx determinant is equal to what? Is equal to what? 69. All right. So what next? We have to find the dy. So my dy is equal to, open my matrix. Now to get my dy, I have to ignore the column in the y matrix. So I will use x and I replace the y with the constant. So for my x, we have 3 and 5. For the constant, we have 1 and 17. Okay, so we'll find the determinant of this 2 by 2 matrix. 3 times 17 is 51. So we have 51 minus 5 times 1 is 5. So therefore, the determinant of dy is 51 minus 5. That gives us 46. So this is how we got our d determinant, the x determinant, and dy determinant. If you missed my video on how to find the determinant of a 2 by 2 matrix, you can click the link above to see how we solve for determinant of a 2 by 2 matrix. So now let's find our x. So therefore, to get the x is equal to determinant dx over determinant of d. And that gives us the x is 69. So we have 69 divided by d is 23. So therefore, 69 divided by 23, that gives us 3. So x is 3. All right. Let's find for y. Y is equal to determinant of the y over determinant of d. So dy is 46 divided by our d is 23. So therefore, my y value is equal to 46 divided by 23. That gives us what? 2. So that is the answer. So my x is 3 and my y is 2. This is my final answer. Now, if you want to check if your answer is correct, you can put the value of x and y into any of this equation and you should get these constants. Let's try it in the first equation. Fourth equation, let's do a check. Let's do a check and see if our answer is correct. Now, the first equation, we have 3s minus 4y equal to 1. We have 3s minus 4y equal to 1. Okay, now x is 3, so we have 3 times 3 minus 4, while y is 2. 4 times is 2. So therefore, 3 times 3 is 9 minus 4 times 2 is 8. So 9 minus 8 gives us what? Gives us 1. That means you are correct. If you are still doubting, We can check it with the second equation, which is 5x plus y equal to 17. Okay. We have 5x plus y equal to 17. Let's see if our answer is correct. So we have 5, x is 3, so 5 times 3, plus y is 2. Okay, 5 times 3 is 15, plus 2. Okay, so 15 plus 2 gives us 17. So we are very correct. So the solution to this equation is x is 3 and y is 2. So if you don't mind, I can write it in this way. X, y is equal to 3 and 2. So this is our final answer. So we can solve equations using Cramer's rule. All right. Now, can you do this? Here is a question for you. Please try your best to work out this question and leave your answers in the comment box below, and I will respond as soon as possible. Thanks for watching. See you next time. Bye-bye.